good afternoon, and wait a minute, it's not afternoon, it's still morning. Whatever time of day it is, welcome back to Dr. Logic Awkwardly Does Logic. Last video, I promised you that we would do a couple more examples to demonstrate validity and invalidity of formulas. So let's just go ahead and get started. Nothing terribly special or fancy is going to be going on. We're just going to use the same techniques that we saw in the previous video on some new formulas. So let's consider something that you might want to express that necessarily possibly P implies possibly necessary P. This is an interesting formula to consider because we haven't actually talked very much about how necessity and possibility interact with each other, or how to understand these sorts of things where you've got two modal operators in front of each other. We'll actually be talking quite a bit about these in videos to come, but for now, let's just use this one as an example. So is this valid? Same technique as last time. What we're going to do is we're going to suppose that it isn't and try to build a counter model that makes it false. If we are able to, then we know that it is invalid. If we run into a contradiction, then we know that it's not. So suppose it isn't. Then, and I'm just going to go straight to drawing the diagram. We know that we have a world W that makes necessarily possibly P true, because that's the antecedent of the conditional, and possibly necessary P false. Now, just a moment, actually. Apologies for that. We had a very brief interruption, but I am back and here to talk about necessarily possibly P being true and possibly necessarily P being false. Now, what we know is that right now, W is a dead-end world. This means, from what we've seen in a couple of videos before, every necessity claim is true. So that one is already taken care of. What we need to do is make this possibility claim false. Now, it's false if there is, in fact, no world that W can see where necessarily P is true. If W can see no world, then nothing will be possible. So this is actually trivially easy to make false. If you have a world that cannot see anything, then necessarily possibly P, implying possibly necessary P, is not going to be valid, it's going to be false. Here's a question for you. What about the converse? So here, the answer to this one is no. What about possibly necessary P, implying necessarily possibly P? Is that one going to be valid? I'll leave that one as an exercise for you. Instead, I want to consider a different one, which is necessarily P and necessarily Q, implying necessarily P and Q. So is this valid? Well, same technique. Suppose it isn't. Then there is a world W where the antecedent of the conditional is true. So we have necessarily P and necessarily Q being true, and the consequent is false. So that's the same as saying not necessarily P and Q. If we have a not necessarily formula, this is, as we've seen before, the same as saying that it's possibly not true. In order for the possibility claim to be true, W has to see a world, let's call it W prime, where this part actually holds. There needs to be a witness to the possibility. So this gets us not P and Q being true, which by De Morgan's we know is going to be the same as either not P or not Q, or possibly both. But now we need to go back here because what we've got is this conjunction between necessary P and necessary Q. So let's separate that out into the two conjuncts, because we know if the conjunction is true, both conjuncts need to be true. What this one says is that every world that W can see, including W prime, is a world that makes P true. So this is a P world. Now we know that either P is false or Q is false, either not P or not Q. Well, we know it's not going to be the right-hand disjunct because we have that P is true. So it follows from these two formulas that not Q is true. Hop back over to our other necessity claim. It says that Q is necessary, so Q also has to be true here. And that is a great big contradiction. At no point did we have to make any decisions about how to construct the model. So this is the only possible way that this formula could be false at a world, if it is in fact possible for it to be false. What this contradiction shows is it's not possible, and therefore this formula is valid. Constructing counter models and demonstrating validity is something that we are going to see again and again moving forward. It's going to kind of not be something we do just for the sake of it, but it's going to feed into other proofs and other results that we want to do. So this is, if you're familiar with this and you're comfortable with it, that's great. If you're not, write down some random formulas, try it out. Try to find out what principles are in fact valid on this system of semantics that we've been given. And start thinking about what principles you would like to be valid. What are ways that you can talk about modality that seem reasonable, at least on a particular conception of modality? We're going to talk about this in the next video, and what we're going to see is that there's a lot of things that we would like to be able to say about modality that we can't necessarily say yet. It will come, and this is why I want you to start thinking about it now. But we are not yet in a position where we can express all of the things that we want to say about necessity and possibility that we might want to say. So there's more to come. Stick with me, and I'll see you next time. Cheers.